Okay, so now that we know how to use the product and the quotient rule and we know about writing equations of tangent lines, we're going to be talking about normal lines and horizontal tangents. So if you'll read the top sentence of our notes, a normal line is a line that is perpendicular to a tangent line at the point of tangency. Remember from previous math classes that slopes of perpendicular lines always have a product of -1, or in other words, they're always opposite reciprocals of each other. So what we're going to be doing is we're going to be using what we know about taking derivatives and finding the equation of the tangent line, and that will help us find the equation of the normal line. So last time we talked about using the product rule and the quotient rule. So we'll be actually using the quotient rule here for our first example. So we want to look for the equations of the tangent line and the normal line to the curve of y is equal to the square root of x over 1 plus x squared at the point 1, 1/2. So the first thing that we want to do is to get an equation of a tangent line, we want to take the derivative of this function. So I'm going to find y prime, and I'm going to do that by using the quotient rule. So our quotient rule says we need to name an f and a g and then take the derivative of both. So I'm going to name my f to be this numerator, but I'm going to rewrite that as f equal to x to the 1/2 power. And when I take the derivative of that, I'm going to bring down the exponent, so 1/2 x, and I'm going to subtract 1 from the exponent, so to the -1/2 power. And I'm going to name this bottom function g, and its derivative will just be 2x. So when I apply the product rule, that's going to tell me to take f prime times g. So I'm just going to write this as it looks right now. I'll clean it up later. So 1/2 x to the -1/2, and then our g is 1 plus x squared. And we're going to subtract from that our f, which I'm going to write just as x to the 1/2 for right now. I'll clean that up later, times g prime, so 2x. And I'm going to put that all over the g squared, so 1 plus x squared squared. And I'm going to simplify this a little bit. I'm going to clean it up. So I'm going to work with these fractional exponents, and I'm going to turn them back into roots. So this is going to be 1 over 2x to the 1/2 times 1 plus x squared minus, I'm going to turn that into a root, so square root of x times 2x all over again this quantity squared. And just one more step to kind of make this look a little bit nicer. So I'm going to turn this into a root, and I'm also going to make this just into one fraction here. So the 1 plus x squared is going to go up in the numerator, and the denominator we're going to have a 2 square root of x. And then I'm going to go ahead and subtract from that. I'm just going to leave this as a square root of x times 2x, and then all over 1 plus x squared squared. All right, so that's pretty much all I need to do in terms of cleaning up the derivative, because I'm really just looking for an equation of a tangent line. So I just want to use this to find my slope. So let's find the slope of the tangent line. And we have our x value. We know that the x value is going to be at 1. So I just want to evaluate this derivative at 1. So when I plug in 1, that's 1 plus 1 squared, so 2 in that numerator, over 2 times the square root of 1, which is just 2, minus the square root of 1 is just obviously 1, times 2 times 1 is just 2, all divided by, this is going to be 1 plus 1 squared, so that'll be 2 squared in the denominator. So what is that? 1 minus 2 over 4, so -1/4. So that's our slope of our tangent line. So we can write our equation of our tangent line now. We have our point, 1, 1/2. We have our slope. So I'm just going to write this in point slope form. So y minus 1/2 is going to be equal to -1/4 times x minus 1. Okay, so hopefully that was a little bit of review. Again, just kind of throwing in some quotient rule practice. But now we're going to look at how to find the normal line. So if we know the slope of the tangent line, the thing about the normal line is actually pretty easy. So the slope of the normal line is actually just going to be the opposite reciprocal of the slope of the tangent line, because again, it's perpendicular. The normal line and the tangent lines are perpendicular to each other. So the slope of the normal line is actually just going to be this fraction flipped over and change the sign. So our slope is actually just going to be a +4. So then from there, I can go ahead and find the equation of the normal line. So again, I'm using the same point. So y minus 1/2 is going to be equal to 4 times x minus 1. And that's basically it for the slope of the normal line and how to find the equation of the normal line. We'll just go through one more example just to show you something that isn't using the quotient rule. So example B, we want to find the equation of the normal line 2y is equal to the square root of x at the point of 4, 2. So again, if I'm looking for the equation of the normal line, we want to find the the tangent line slope first. So that means I'm going to definitely have to take this derivative. I'm just going to rewrite this as y is equal to x to the 1/2. And then I'm going to go ahead and use my power rule to get my derivative. So 1/2 x to the negative 1/2, which if I rewrite that a little bit cleaner, would just be 1 over 2 root x. I kind of showed why that happened up here in the first example. But if you have any questions on it, you can definitely let me know. So I'm just going to go ahead and find the tangent line slope. So I'm going to just evaluate y prime at the x value of 4. So y prime of 4 would be 1 over 2 times the square root of 4. So that'll be 1 over 2, 1 over 2 times 2. So my tangent line slope is going to be 1/4, which means that my normal line slope is going to be that opposite reciprocal. So that would mean that my slope would be -4. So I'm looking for the equation of the normal line. So once I have the slope, I already have the point here. My equation, again, I'm just going to leave this in point slope form, would be y minus 2 is equal to -4 times x minus 4. And that's all I'm looking for is the equation of the normal line. A little bit more basic, again, not using the quotient or the product rule here, just kind of using the power rule. But you definitely want to be comfortable working with these fractional exponents and kind of turning them back into roots, especially for something like this when you're just going to be taking a square root of a nice number that's going to give you an integer. You should definitely know how to manipulate these. All right, so that's basically it for equations of normal lines. Now we're going to be talking about horizontal tangents. So we talked a little bit about this when we were looking at the graphs. But we know that a tangent line is horizontal when the derivative is 0. So think about like when we were looking at graphs of kind of like, I don't know, curvy shapes like this. Remember we were saying that the tangent line is horizontal here and here, and that would mean that its derivative would be 0 at those points. So that's all we're talking about when we're talking about a tangent line being horizontal. So to kind of apply that, we want to find the points on y is equal to x to the 4th minus 6x squared plus 4 where the tangent line is horizontal. So basically that's asking us to look for, well, where is the derivative 0? So at what points is the derivative going to be 0? Well, obviously I would need to take a derivative if I don't have one yet. So I'm going to go ahead and use the power rule here to get the derivative of this y equals. So that'll be 4x cubed. I believe just minus 12x because the derivative of 4 is just going to be 0. So now I want to know, well, where is this going to be 0? So I'm going to go ahead and take that derivative and set it equal to 0. And then I'm just going to manipulate this algebraically to figure out, well, where are the x values 0? So I can factor out a common factor of 4x. So that'll leave me with x squared minus 3. I'm going to use the zero product property here. So 0 is going to be equal to 4x, or 0 is going to be equal to x squared minus 3. So this will tell me that I'm definitely going to have a tangent line horizontal at the x value of 0. Over here, I'm going to have x squared equal to 3. So my x is going to be either plus or minus the square root of 3. And you definitely do need to have the plus or minus here because we are talking about different points on a graph. So if you just take the positive, you're going to definitely miss one of your x values. So I know that I have an x value of 0, I have an x value of positive root 3, and I have an x value of negative root 3. So to find the points, we're going to go back up to the original f of x, or the original function here. So I'm looking to substitute in these 3 x values into the original function. So I'm going to go ahead and evaluate, well, what is f of 0? So that's going to be 0 to the 4th minus 6 times 0 squared plus 4. So that'll give me a 4 here. I'm going to go ahead and do the same thing for the positive root 3. So that's going to be positive root 3 to the 4th minus 6 times root 3 squared plus 4. Root 3 to the 4th is actually just 3. So that'll be minus 6 times root 3 squared is just 3 plus 4. So 3 minus 18 plus 4, I believe, gives me a negative 11. And I'm going to go ahead and do the exact same thing for that negative root 3, which actually ends up being exactly the same as the positive root 3. Because if I go ahead and do that algebra, negative root 3 to the 4th is still 3, minus 6 times negative root 3 squared is still just 3, plus 4 equal to negative 11. So my points are going to be 0, 4, root 3, negative 11, and negative root 3, negative 11. So those 3 points are where my tangent line would be horizontal. All right, let's look at one more example using the quotient rule. So now we're looking for points on this function. So again, this function is a fraction, so we should be thinking about using the quotient rule here where the tangent line is horizontal. Again, tangent line, we should be thinking about derivative. So I definitely need to get the derivative of this stuff. So I'm going to set my f to be the x squared. That's going to tell me my f prime is 2x. I'm going to set my g as the 2x minus 1, which means that g prime is actually just going to be 2. So when I go to find y prime, I'm going to go ahead and multiply my 2x times the 2x minus 1. I'm going to subtract from that the x squared times 2, all divided by the g squared, so 2x minus 1 quantity squared. So I'm just going to clean this up a little bit. So y prime is going to be equal to 4x squared minus 2x, and then that's going to be minus 2x squared all over 2x minus 1 squared. And just one more step to just kind of make it look a little bit nicer. My numerator is going to be 2x squared minus 2x, all divided by 2x minus 1 quantity squared. So again, I'm looking for the places where this is going to be equal to 0. So I'm going to go ahead and set that equal to 0. 0 is equal to 2x squared minus 2x, all divided by 2x minus 1 squared. When you multiply each side by the 2x minus 1 squared, that quantity actually ends up canceling out. So what we are left with is just setting 0 equal to 2x squared minus 2x. I'm going to go ahead and factor out a GCF of 2x here. So I get 0 is equal to 2x times x minus 1. Using my zero product property, 0 would be equal to 2x, or 0 would be equal to x minus 1. So that's going to give me an x value of 0 or an x value of positive 1. So to find the points, again, I'm going to go ahead and go back to my original function or my original f of x. So I'm going to go ahead and evaluate f of 0. So that'll be 0 squared over 2 times 0 minus 1. That'll give me 0 over negative 1, which is just going to be 0. And then f of 1 would be 1 squared divided by 2 times 1 minus 1. So is that 1 over 2 minus 1? So 1 over 1. So 1. So my points where my tangent line is going to be horizontal would be at the point 0, 0 and at the point 1, 1. All right, so these practice problems are going to be due in class on Friday. I just want you for today to just upload a picture of your notes, and that will count as your attendance. Let me know if you have any questions on anything.